The Height of Homo floresiensis by Caroline Ward. Introduction. The word hobbit invokes images of small child-sized hominins traveling around on epic quests. This makes hobbit the perfect nickname for Homo floresiensis, who lived during a time with several other different Homo species, and whose discovery led us on an epic journey in evolutionary research. The type specimen for this species, LB1, was first described in 2004 and was originally believed to be from around 18,000 years ago. Extensive testing on sediments in Lingbao Cave found that these fossils were likely to be no younger than 46,000 years old. It is currently believed that Homo floresiensis lived between 100,000 and 50,000 years ago. Some of the distinctive features of Homo floresiensis are their small brains, large teeth, receding foreheads, relatively large feet, and of course their small stature at approximately 3 feet 6 inches tall. Thesis statement. In this presentation, we will examine some of the debates surrounding the small stature of Homo floresiensis, including the pathological argument, the island dwarfism theory, and the small ancestor theory, and how these debates have impacted the study of evolution. The pathological theory. This argument centers around the idea that the fossils found on the island of Flores were not new species, but fossilized Homo sapiens. Researchers have argued that the fossils at Lingbao Cave represent a small group of Homo sapiens that were all affected by a developmental delay or syndrome. Two of the conditions considered are Down syndrome and endemic cretinism. Evidence of Down syndrome diagnosis. Some researchers believe that LB1 is a member of Australo-Malaysian Homo sapiens with developmental abnormalities. Australo-Malaysians could have entered Flores Island as they traveled down and into Australia. In Homo sapiens, reduced endocranial volume is common in people with Down syndrome. Anthropometric data finds that people with Down syndrome have greater shortening of the lower limb than the upper limb. LB1 showed signs of both of these. If Homo floresiensis is actually Homo sapiens, then short stature would also be considered a sign of Down syndrome. Challenging the Down syndrome diagnosis. Researchers who disagree with the diagnosis of Down syndrome point to the fact that to definitively confirm a diagnosis would require genetic testings. Currently, with the limitations of genetic testings, we are not able to do this. When compared to 6 female patients with Down syndrome and a group of 30 adults of mixed sex, the endocranial volume of LB1 was significantly less. These numbers are listed to the left. Anteriorly projecting face and posteriorly sloping frontal squama of LB1 are not consistent with individuals with Down syndrome, but instead suggest a relationship with early Homo. Evidence of endemic cretinism diagnosis. Cretinism is a type of dwarfism found in Indonesia and Africa today. This is an environmentally driven disorder that stems from iodine deficiency. This could have affected several Homo sapiens in the area, and all individuals would have been born without a functioning thyroid. In Africa, the mean stature of an adult male with cretinism was approximately 70% of the average male height. This ratio is similar to the estimated height of LB1. Depressed nasal bridges, projecting jaws and teeth, and underdeveloped chins are all cranial features common with Mixoendematous endemic cretins. Human cretins have long arms relative to legs, similar to the measurements of LB1. The estimated pituitary fossa of LB1 is enlarged compared to the brain size, similar to African Mixoendematous endemic cretins. Challenging the endemic cretinism diagnosis. One problem with identifying Mixoendematous endemic cretinism in LB1 is that the fossils have been damaged. For example, the area of the nasal bridges was damaged and reconstructed. Clinical descriptions of skeletal and dental characteristics of cretins have been consistent, but LB1 does not completely match this description. Forward projecting jaws and teeth are common in cretins because of their mixed or deciduous dentition. Even though LB1 is damaged, there is no evidence of an overbite or substantial anterior malocclusion. Homo sapien cretins have an endocranial volume and brain mass that is within the normal human variation, but this is not true for LB1. The cave Ling Bao, where Homo floresiensis was found, shows signs of hominins that hunted stegodon and made stone tools. These activities may have been too difficult for a Homo sapiens cretin. Their locomotion as well as their intellectual skills are impaired with this condition. Is LB1 Homo sapiens? The skull of LB1 does not support the idea that Homo floresiensis is not its own species, but a member of Homo sapiens. Homo floresiensis proportions are unique and are not similar to recent or fossilized Homo sapiens. Finally, there is no sign in the current fossil record of anatomically modern humans until around 11,000 years ago in this area. The island dwarfism theory. This theory relies on the island rule. The island rule suggests that some species that become isolated on an island will either evolve towards dwarfism if they are a large animal, or evolve towards gigantism if they are a small animal. There are several theories about why this happens, and one of them is resource availability. Are primates subject to the island rule? When studied, it was found that all small island primates, less than 5 kilograms, are larger than their mainland relatives. Some of the primate species used were less than 10,000 years old and still showed significant dwarfing. The degree of size reduction seen in LB1 when compared to Homo sapiens and Homo erectus is within the range seen in other primate species. Other evidence of island dwarfism. Other species on Flores Island seem to also be following the island rule. For example, stegodon were dwarfed elephant-like species that lived on the island, and rats became larger. There is little evidence to support the island rule applying to brain size in primates. It takes a lot of energy to create brain mass, and following the island rule, it is possible that the species would reduce the brain size in order to reduce the total energy because of limited resources. Challenging island dwarfism. When using Homo erectus as the direct ancestor for Homo floresiensis, models do not overwhelmingly support the insular dwarfism theory, at least for brain size. models did show that body size fell within the parameters of what would be expected when applying the island rule to this species, but they were not able to align the reduction of brain size and body size. Finally, island dwarfism is not universally seen in mammals on all islands. This means that we cannot assume that if Homo erectus or Homo sapiens washed up on the shores of Flores, it would have been subject to the island rule. The small ancestor theory. The ancestor of Homo floresiensis may have been small before it came to the island. This theory suggests that Homo erectus may not have been the direct ancestor to Homo floresiensis. Small ancestor evidence. LB1 has many skeletal morphologies similar to early Homo, such as lower maximum cranial width, occipital torus, and well-developed brow ridge. Comparing LB1 to other Homo species has led to the theory that Homo floresiensis is most closely related to Homo habilis, or a similar evolutionary grade. Researchers have created several models of the evolution of Homo floresiensis, and in each model, Homo habilis is suggested to be a closer species than Homo erectus. Homo habilis was smaller than Homo erectus at only 118 centimeters, closer to Homo floresiensis, who is around 106 centimeters. Challenging the small ancestor theory. If LB1 dwarfed from Homo erectus, then the forearms would have had to dwarf at different rates. There is some evidence to support this possibility in Homo sapiens. The configuration of LB1's endocast suggests that the prefrontal cortex and the wide temporal lobes are conditions relative to Homo erectus. For this theory to be correct, Homo habilis would have had to have left Africa, but currently the fossil record does not support this theory. Conclusions. Clearly, the subject of the height of Homo floresiensis has been an intensely debated topic since its discovery. Both the pathological theory and the island dwarfism theory have been popular since the discovery of Homo floresiensis. The island dwarfism theory seemed like the most likely explanation when the fossils were first found. Researchers knew that Homo erectus fossils had been found in the area, and that they could have migrated to the island. The pathological theory was meant to explain the young age of the fossils when they were first found, but became less prominent when the fossils were redated. The small ancestor theory has become more popular in recent years. With the discovery of Homo floresiensis, the anthropology community has gained not just a new species, but also a new way of thinking. Homo floresiensis challenges the linear view of evolution, and it has made the community examine the possibility that earlier Homo species left Africa a reality. Homo floresiensis has given us a new perspective on evolution. References page 1. References page 2. References, page 3.